we have line to line ground fault. Here the word itself only shows that means three lines will be there, R, Y and B, and after the when getting sorted it is getting also grounded also. So such type of fault is called the line to line ground fault. Line to line ground faults. So in this system what is happening, three of the conductors are getting sorted and it is getting grounded also. So such type of the occurrence of the fault is very rare in very rare nature. A three types of fault occurs when all the three conductors R, Y and B are getting in contact with the ground simultaneously. So such type of fault is called the line to line ground fault. So I have written here, a three-phase line to ground fault includes all the three phases of the system. The line to line fault occurs between the three phases and the ground of the system. The probability of the occurrence of such type of fault is nearly 2 to 3%. It occurs very rarely in nature, and it varies from the 2 to 3%. Somewhere it is written less than 10% also the occurrence of the such type of faults. So in the diagram we can see here we have the three conductors R, Y and B. When they have sorted and it grounded also, such type of fault is called the line to line ground fault. Next one we have the a three phase line to ground, that is L2G fault, occurs when all three phases conductors R, Y, B come into contact with the ground simultaneously. This means each phase is sorted to every other phase and to the earth at the same point. Also we have shown here that it is getting sorted at the same point only. In the diagram also I have shown here that whenever the fault occurs at the system, all of them are getting, after getting the breakage, so it touches the ground only and the here only at the same point only. The key features of this fault are, even though ground is involved, the three phases remain equal in magnitude and displaced by the 120 degree, as same as we have seen in the line to line fault. Only the positive sequence network is required for the analysis, like a pure three-phase fault. Already we have discussed in the last section also that we requires only the positive sequence network for the analysis of the three-phase fault whenever it occurs. It produces very high current, often slightly higher than a simple three-phase fault because of the earth path. It determines the short circuit MVA rating of the circuit breakers, bus bars and the transformers. Already we have discussed this point. Rare compared to the single line to ground or the double line to ground fault. It is very rare. It occurs very rarely, that we see very rarely whenever the three of the line is getting touched and the fault occurs. It occurs 2 to 3% of the system fault. Next topic that we have, this type of fault causes because of, first point, simultaneous insulation failure of all the three faults. It occurs whenever the insulation getting failure of all the three faults. Next causes we have the mechanical damage. Example, the tower collapse, severe flashover during the lightning, or the equipment explosion. Means this type of the fault occurs because when tower collapse, severe flash over during the lightning, or the equipment explosion. Next one we have that the incorrect switching or the catastrophic breaker failure because of the incorrect switching. Also this type of fault occurs in the system. The effect of these faults are complete voltage collapse at the fault point. Means already I have told you the one point is that it mainly occurs at the generation side, at the generation side, not in the transmission side, not in the utilization side. That's why this type of fault can be also called that the generator fault. Next one, we have the enormous short circuit current flowing through the both phases conductors and the ground return path. Because of this fault, enormous short circuit current flowing through the phases conductors and the return path. Next one, we have the heavy thermal and the mechanical stress on the conductors, transformers and the generators. Next, how can it be protected? It can be protected by the detected by the overcurrent or the differential relays that sense the symmetrical high current in the three phases. The last point that we have, the high speed circuit breaker must interrupt the circuit quickly to prevent the equipment damage. So these all are the depth discussion regarding the faults. So this is the entire story from the definition through types, features, causes and the effects of the protective measures and the link with the short circuit capacity, presented in a single continuous explanation suitable for a lecture. Thank you.